Welcome! Today we're going to break down a geometry problem involving an isosceles trapezoid and a circumscribed circle. The problem gives us an isosceles trapezoid with a longer base AD of 21, a shorter base BC of 9, and a height of 8. Our goal is to find the radius of the circle that this trapezoid is inscribed in. To find the radius of the circle around our trapezoid, we'll focus on triangle ABD because the circle that circumscribes the trapezoid is the same one that circumscribes this triangle. We will use the standard formula for a triangle's circumradius. R equals the product of the side lengths, A, B, and C, all divided by 4 times the area, S. To apply this formula, our first task is to find the lengths of the sides of triangle ABD. We're already given that side AD is 21, so let's proceed to find the other two sides. So let's begin by finding the length of segment AE. On this first step, we will find the length of segment AE. We need this length because it forms the base of the right triangle ABE, which will allow us to find the side AB. Since the trapezoid is isosceles, the length of AE is half the difference between the bases. So AE is 21 minus 9, all divided by 2. This is 12 divided by 2, which gives us 6. Now we will find the length of the non-parallel side AB. This is one of the 3 sides of triangle ABD that we need for our final formula. We'll use the right-angled triangle ABE and the Pythagorean theorem. We know AE is 6 and the height BE is 8. So AB is the square root of 6 squared plus 8 squared. That's the square root of 36 plus 64, which is the square root of 100. The length of AB is 10. Next, we need the length of ED. We need this segment because it's the base of the right triangle BED, which we'll use to find the diagonal BD. To find ED, we simply subtract the length of AE from the full length of the base AD. This is 21 minus 6, which equals 15. With the length of ED, we can now find the length of the diagonal BD. This is the last of the 3 sides of triangle ABD we need to find. Using the right-angled triangle BED, we apply the Pythagorean theorem. BD is the square root of the height, BE squared, plus ED squared. That's the square root of 8 squared plus 15 squared, which is the square root of 64 plus 225. This gives us the square root of 289, so the length of BD is 17. Finally, we can calculate the radius, R, of the circumscribed circle. This is our main goal. We have all the pieces for triangle ABD. Side AB is 10, side BD is 17, and side AD is 21. We will use the formula R equals the product of the sides divided by 4 times the area. First, let's calculate the area of triangle ABD. The area is 1/2 times the base, AD, times the height, BE. That's 1/2 times 21 times 8, which equals 84. Now we substitute everything into the radius formula. R equals 10 times 17 times 21, all divided by 4 times 84. The numerator is 3,570, and the denominator is 336. The fraction 3,570 over 336 can be simplified. If we divide both the numerator and denominator by 21, we get 170 over 16. Dividing 170 by 16 gives us our final answer, 10.625. The radius of the circumscribed circle is 10.625. That's how we solve the problem. We use the properties of an isosceles trapezoid and the formula for the radius of a circle circumscribed around a triangle to find the solution step by step.
If you have found alternative ways to solve this problem, or if you noticed any errors in our reasoning, please feel free to leave a comment below. Your insights are always welcome. Don't forget to subscribe to the channel for more geometry lessons. Until next time.